Hi. Now I've got here a typical example that you'll get in many textbooks and possibly on exam papers based around the compound angle formulae. What we've got is if A is an obtuse angle and B is a reflex angle, where sin A equals 3/5 and the cosine of B equals 5/13. Find the exact value of sin of A minus B and then the tan of A plus B. Now, when I get students doing questions like this, their first reaction is, okay, well, why can't I get on a calculator, just work out what angle A is by doing the inverse sine of 3/5 and get what B is by doing the inverse cos of 5/13, and then just subtracting the angles, take the sine or add them and take the tan. Well, that's all very well, but you won't necessarily get exact values when you do the inverse sine and the inverse cos of these values. So how can we do this without working out the angles A and B? Well, this is how I would suggest you do these type of questions. What we do is we start by drawing the quadrants. Remember the quadrant diagrams? If you're not familiar with the quadrant diagrams, just look on the website and look for the tutorial video on quadrant diagrams. What I would do is one diagram for angle A and a diagram for angle B. Now when we talk about angle A, first of all, it's an obtuse angle. And that's an angle between 90 degrees and 180 degrees. And on these quadrant diagrams, we always start with 0 degrees here, and we work our way around in an anti-clockwise direction. 90, 180, 270, 360. So when we're talking about an obtuse angle between 90 and 180, in other words, then we've got to draw something in this quadrant here. So draw your line coming out here and complete the triangle down to the horizontal line here. So angle A is our obtuse angle. It goes round here. That's our angle A, and I'd mark it in like that. And we're told that the sine of angle A is 3/5. That means we work off this angle here. And for sine, sine is opposite over hypotenuse. So the ratio is 3 to 5. Now we've got to work out this side, the remaining side of the triangle, and you can do this by Pythagoras' theorem. Although you should know this is a well-known triangle, you quite often get these in these kind of questions. It's what we call the 3, 4, 5 triangle. This side turns out to be 4. But as I say, you can do it by Pythagoras' theorem. This side is the square root of the hypotenuse squared, 5 squared, minus 3 squared. 25 minus 9 leaves you with 16. Square root it and you get the 4. Okay? Right, let's do the same for angle B. Angle B now is a reflex angle. And you have to think about this. A reflex angle is between 180 degrees and 360 degrees. So the question is, where is B going to be? Which quadrant is B going to be in? Is it going to be in the third quadrant or the fourth quadrant? Well, the clue or answer is given by the value here, 5/13. It's a positive value. And can you remember from the quadrant rule, we have in the first quadrant all trig ratios are positive, then its sine is positive, tan is positive, and cosine is positive. So cosine is positive here, so it's in the fourth quadrant. So what we need to do is draw a triangle in here, starting from there, project back onto the horizontal line, and you've got your triangle. and this will be angle B, starting from here, going round anti-clockwise, and I'd mark that in. If it said that cosine B was minus 5/13, then cosine for a reflex angle is negative in the third quadrant here. So I would have drawn this triangle out in this quadrant. Anyway, cos B is positive, so we've ended up in this quadrant. Now we need to mark in the sides. Cosine is adjacent over hypotenuse, so we're working off this angle in here, and the adjacent side would be this one, so that would be 5, and the hypotenuse is this one, 13. And this too is a well-known triangle, Pythagorean triangle, often referred to as the 5, 12, 13 triangle. But again, you could work it out by Pythagoras' theorem. Square root of 13 squared minus 5 squared. That will give you the 12. Okay, so once you've set these two quadrants up for your angles, A and B, in any question, what we can now do is turn to the appropriate formula for each of these. We've got the sine of A minus B. So the sine of A minus B, hopefully you remember what that is by now. For this, it's going to be equal to sine of A cosine of B, and then it's minus sine of B cosine of A. Now what we've got to do is fill this in with the particular values for sine of A. As I say, we don't need to work out what angle A is. Sine of angle A, well, we know up here it's 3/5. Or we could just work off the diagram, opposite over hypotenuse, 3 over 5. So we've got 3/5 for this. Now we've got the cosine of B. Again, we could see that cosine of B is 5/13, or we could work directly off the diagram, adjacent over hypotenuse, 5 over 13. Minus, now we've got sine B cos A. Do you know what those values are going to be? Well, you've got to be very careful with these ones, as you'll see. When we get to sine B, okay, we're working off this diagram, and sine is opposite over hypotenuse. So immediately you might think, okay, opposite side is 12, hypotenuse is 13, and just simply put 12 over 13 in here. If you did do that, you would be wrong, because you've got to be careful. Remember the quadrant rule. It's all a positive in this quadrant, sine is positive in that one, tan is positive in that one, and cosine is positive in this one. So when it comes to doing the sine of angle B, sine is negative in this quadrant. Only cosine is positive. So I'll put this in red just as a kind of warning. That minus has got to be there. Okay, next up, cosine of A. So we're over to this diagram. So when it comes to the cosine of A, cosine would be adjacent 4 over hypotenuse, 5, 4/5. But again, you've got to be careful, because cosine is negative in this quadrant. So what we've got is minus 4/5. And again, I'll just put the minus in red as a kind of warning. Alright, well, we've got this far. All we need to do now is just work out what these fractions are. This one comes to 3 5s, which are 15, over 5 13s, 65. And then you've got the minus here, and you've got a minus times a minus is a positive value, and you've got 12 4s are 48, over 13 5s are 65. And when you work that out, 15 take away the 48 gives you minus 33 over the 65. Minus 33 over 65. Okay, well that gives us the exact value for this example. And you might like to try this one now, the tan of A plus B. So just pause the video if you want to have a go. Okay, well let's just see, if you had a go, how you got on. So tan of A plus B. Hopefully again you know the identity for this. It's the tan of angle A plus the tan of angle B, all divided by 1 minus the tan of A times tan of B. So over to here. Now tan of A is going to be opposite over adjacent, so that'd be the 3 over the 4, 3/4, but again we've got to be very careful. Tangent is negative in this quadrant. Only sine is positive, so it's going to be minus 3/4. So we've got minus 3/4 there. Let's just put that in brackets, and then we've got the plus, and now we need the tangent of B. Tan of B, use this triangle, opposite over adjacent, 12 over 5, but tan is negative in this quadrant, so it's going to be minus 12/5. Now we have those values, we can fill them in on the bottom here. We've got the 1 minus tan A, minus 3/4 then, multiplied by tan of B, which is minus 12/5. Now you could work this out on your calculator if you like, or what I normally do when I've got something like this, I multiply top and bottom by 20, the 4 times 5. When I come to multiply this term by 20, 4 will go into the 20 5 times, and I'll get minus 3 times the 5, minus 15. When I look at this term, multiply this term by 20, 5 will cancel into 20 4 times, 12 4's 48, so I end up with minus 48. Divide this, got two terms here, the 1 and all of this term, times the 1 by 20 and you get 20. This term, times it by 20 and the 4 and 5 cancel out, and you're just left with minus 3 times minus 12, which is plus 36. Then with this minus, it's going to make minus 36. So I hope you could follow that, but if not, as I say, you could just use your calculator and just work it out. When you work this out anyway, you end up with 63 over 16. 63/16 then, the exact value for the tan of A plus B. Okay, well, I hope that's given you some idea how to handle questions of this nature. Draw your quadrant diagrams. Remember though which quadrants give you positive and negative values for sine, cos and tan. That's the place that I find people tend to go wrong. Okay?